Can I have your attention, please? Welcome to Track 2 for HouSecCon. I'm Sam Denard. I work for HP's Fortify on Demand, and I'll be your host for Track 2 today. If there's anything I can do for your listening pleasure, please let me know. We're just about ready to begin. I'd like to introduce our speaker, Stephen Coty. He is the Chief Security Evangelist at Alert Logic and a member of ISSA, InfraGard, and HTCIA. His research has been his primary focus and passion since 2007. Okay. He's an experienced speaker, having presented at RSA conferences, AWS reInvent, US Cybercrime Conference, and others. Okay. And he's been working in security since goodness only knows when, 1992. Okay. And he's going to speak to us today on forensics and incident response.
How's everyone doing this morning? Yeah. All right, let's do this. So who here does forensics as a forensics investigator, or have any of you guys dealt with any cloud environments yet? Yes? No? Yes? Few? Okay. Who has deployments in the cloud? That might be a good, excellent. So this might apply to a lot of you. So cool. So forensics in the cloud is a little different beast than traditional forensics. And the sooner you realize that, the easier your job as an investigator or just as a security professional is going to be. As we've seen throughout the years, cloud is becoming more and more a place for enterprises to put business. There's different types of clouds. As there's some statistics up there talking about revenues and VDI market. VDI market's actually really interesting because, as people are moving to virtual desktops in the cloud, they're kind of going away from that BYOD policy that they felt introduced too much risk into their environment. So with a VDI environment, at least they have, a workstation that's in private IP space. They could centrally manage the antivirus and patch management process, where in a BYOD policy doesn't really happen that much. So we're seeing more and more enterprises for that reason moving more and more desktop workload to the cloud. Just looking at what Gartner is saying, about 60% of banking institutions. Healthcare has a big push this year to start moving to the cloud. Universities have mandates. I've talked to probably 5-6 universities around the country, and they actually have mandates where they have to move between 70 and 80% of their workload into the cloud, just for that lower cost of ownership. So cloud is becoming more and more attractive every day for more and more businesses, which means now the traditional things we used to do in the enterprise, like forensics investigation, is now moving out into the cloud. And of course, the bad guys are going after it as well. We do a cloud report every year, so we have about 3 years of data, and we've been tracking to see what type of attacks are actually taking place. As you can see, vulnerability scanning went from 27% to 44%, pretty significant jump. Brute force from 30 to 44, and the malware botnet from 5 to 11%. Not a huge number still, but still a 100% increase. So as we see more and more different workloads moving there, we're going to see a lot more of this malware botnet type of attack, especially with VDI, because now where are people opening their email? On the cloud instance. Where are they doing their web browsing? On the cloud instance. So you're going to start seeing a little bit more targeted attacks against that type of environment. So what we've done to collect data is we've deployed a global honeynet of Honeypot servers. Everybody know what Honeypot server is, first of all? Awesome. I am in the right room. So with the Honeypot servers, we have deployed several different types. Kippo being my favorite. I like Kippo. But there's Dianea, which is a very low interaction type honeypot. Reason why I like Kippo is because it goes a little beyond just the average honeypot. It actually starts keylogging the attacker's keystrokes as he's attacking you. And even after he disconnects from the server from his attack, it maintains a connection with him and continues to collect his keystrokes. So that means during your investigation, You can find out email addresses. Maybe this guy's logging into his email address, because if anybody's done this at any time in their life, you know you don't just focus on that one thing all night long. You have usually 3, 4, 5 different screens going at the same time. So as he's waiting for processes to run here and he goes and checks his email, great opportunity to find and start profiling the guy. Who is he? What's his email address? Is he associated with any type of legitimate organization or a crew out there from the underground? We found that there was a lot of different hits across the globe. It all depends where you were at. We found that Microsoft Directory Services, port 445, was the #1 attack vector. We had over 51% of the attacks were port 445. Everybody knows for port 445, it's anybody been having to solve networking issues with NetBIOS back in the day? Well, 445 is the routable IP replacement for NetBIOS, where you can now, if you have multiple cloud servers, you can set up drive shares between each other. So that tells you what the attackers are looking for. They're looking for file data. They're looking for intellectual property. They're trying to use it as a jump point a lot of times. So we found that the highest attacks that we saw were in Europe, which I really attribute a lot to. A lot of the malware writers are actually in Europe. So in order for some of their botnets to successfully test, they have to test in their local region, because they can't go over international lines, because that adds a latency which might confuse the botnet and it might not give the proper response to actual malicious actors who are writing this. So they do a lot of testing in their own backyard. We found that a lot of it was hitting Northern Europe, was hitting Western Europe, Ireland, the UK, France. A lot of it was originating from like the Netherlands and Eastern Europe. So a lot of testing taking place. As you can see, besides Microsoft Directory Services, databases were continually the #2 target in every single region around the world. And we have these servers deployed across multiple service providers in every region, as I mentioned. An interesting thing we saw was that 14% of the malware that was launched against our Honeypot infrastructure was not detected by antivirus. So I'm not saying antivirus is dead, because it's not. It has a place in a security in-depth strategy that you might implement in the enterprise and in the cloud, but it doesn't catch everything. So, and you'd be surprised. I mean, out of that 14% was old versions of Zeus configured. I mean, things we've been seeing since about 2007. But these guys keep rewriting the code to bypass AV controls. And so then they have another marketable piece on the market ready to go. So in order to catch these guys and run forensics investigation after these type of attacks are taking place, you first really need to understand the cloud and understand where you are inside the cloud environment. Because there's 3 different versions of cloud. There's basically a private cloud, which is in the back end of a hosting provider space, and it's non-routable IPs, and it has a point-to-point connection between the infrastructure inside this service provider and your enterprise environment. So it's a point-to-point, just like a VPN tunnel going back and forth. Then you have kind of the hybrid cloud, which is maybe somebody who might have like credit card campaigns do this a lot, where they have a database server that they'll drop in the private cloud, and then they'll have a public web interface on the public cloud for people to access the data. But then between there's a point-to-point, IP-to-IP, port-to-port connection between the private and that public cloud instance. And then of course there's public cloud, just going out to Amazon, spinning up some servers, and doing whatever you need to do. Anybody suffering from any shadow IT kind of situations, where people within your organization are spinning up servers without you even knowing. They're doing testing of your enterprise data out there without IT even being involved in part of the process. I'll take a sidetrack right here and just talk about a few technologies that you can find that stuff in your environment. So there's actually a couple of vendors, I didn't see them here today, that do this as part of their process, but an easy way to do it is actually through your web filtration products, or through some type of NetFlow collection where you're collecting IP addresses. Because what you can do is you can actually blacklist those CDNs that belong to the different hosting providers, where it's going to send you an event or an alert every single time somebody within your organization goes out to one of those service providers to log in and actually get to their cloud server. So it's a great, easy, inexpensive way for you just to find out who in your organization is actually utilizing the cloud. Because I've been in a lot of places where, dev groups will go spin up their own environments, use a credit card, expense it. IT groups try to wrangle it, try to manage it, bring it in-house, make sure, what are you putting out there? What's our risk? What type of data are you placing out in the cloud? And then that's always a constant struggle for IT. So that's why I always thought of an idea of like using the web filtration, because if they're going to go out to the console to manage their environment, they're going to hit IP space belonging to that service provider. So it's a great way just to find out who in your organization is actually utilizing the cloud. So to understand the cloud, you got to understand how the cloud services kind of work. So there are several different pieces of architecture here. You have DOM0, which is basically your management operator. This DOM0 controls all the hypervisor, the hardware, the CPU, disk, and allocates it to users, which are DOMU. So we have 2 Linux users and a Windows box there. That's how the hypervisor works in basic functionality, because it just allocates memory, hard drive space, CPU, to the particular instance. So how does it actually function? Now, we've seen a lot of hypervisor exploits this year that have come out that have been letting people, like a regular user will sit out here in ring 3, which is considered the application ring. That's where you as a consumer have all your data and where you do all your job. Now, the ring 0 is actually where all the hypervisor and DOM0 take the control. That's where they allocate resources. In some actual architectures, Intel and AMD came out with a ring -1 because they wanted to balance the resources a little bit more. But this is pretty much the typical process that you're going to run. So how do we do forensics within that type of environment? And why do we do it? There's a lot of cybercrime out there, not on top of just the people actually getting compromised, but there's a lot of activity, like there's organized crime, there's violations, data recovery, which happens intentionally or sometimes accidentally. But some of the things that we found, like right here, this selling good stuff, I actually found that on a cloud server where this guy was out there selling credit card data. So we had to scrape all the data and try to link it back to the banking node institution that issued the cards, let them know that they had some data leakage. Because this guy was out there selling it. Because why? The cloud is a great place for malicious activity to occur. The early days of cloud, I used to call it a cesspool of activity, because these guys can spin up a cloud with a stolen credit card that they bought, and they could be online for 90 days before they get kicked off the network. So what happens is the first 30 days, credit card gets charged. Maybe the person finds it because they watch their credit card statement every month. Maybe they don't. Let's assume they do. So at the end of that 60-day period comes, the second month, they bill, and they get a response back saying, well, the card didn't go through, maybe the date changed, maybe something happened. So they actually give them a grace period of another 30 days. So that's 90 days that malicious activity can be taking place on the cloud. That's where you see these guys who steal this credit card, spinning up cloud servers, and starting to sell their data through it using one of the stolen credit cards that they took. So, and of course we get lots of interesting credit card data, usernames, passwords, and of course your regular 4chan type of stuff with the celebrity photos and things like that. So, what are some of the challenges? It's really, you really need to understand the provider. And that's the tough part, because every provider is different. Each provider offers different services, but they're all the same in the core. Because when we have to run forensic investigation, it really becomes a partnership between the investigator, the client, and the service provider. Without all 3 of them, it's not going to work, because as an investigator, you're not allowed in the data center floor. They won't let you. They don't care who you are. I've seen them actually walk feds off of the floor after somebody accidentally let them on, because it goes against the contracts that they have with their customers. Now, that doesn't happen in all data centers, I can assume. But how do you find the specific instance without you being able to physically go to it, touch it, pull the hard drive, image it? That's the way we've always done that. So there's a couple of techniques that you can go ahead and do this. But it's really, really tough because now the data gets tainted because you can't just go in there and get it the day that you're contracted to go out and do the investigation. You have to submit a ticket. And it has to come from the customer. And the customer has to grant you access to interact with the service provider. And then you submit a ticket. Then the ticket gets routed to some server administrator that just goes and makes a copy of an image, not thinking, does this have to be forensically sound? I'm just copying this image and I'm putting on a drive and I'm giving it back to the client service rep who's then going to contact the customer and say, we have your drive ready. How do you want it? Do you want us to ship it to you? Do you want to come get it? Depending on location. So it becomes a real nightmare because by the time you actually get the drive, run the investigation, days have already gone by and you don't have, the up-to-date data. I mean, everything's been tainted. The server administrator, when he made changes and copied the files, modified all the dates, so there goes that out the window. So what do? It becomes very, very hard to work through a service provider. Some more challenges, obtaining assistance from the infrastructure, the provider staff, like I mentioned. It's a process. You have to submit a ticket. It's not like you just pick up the phone call. And some of these things, once they get their legal department involved, oh man, then it goes beyond just days. Then it gets into weeks because then they got to review the paperwork. They got to make sure what you're doing isn't grabbing other people's data on that same instance. The topology, policies, storage, how does that happen in the cloud? Where is the data? Is it in their data center in Chicago? Is it in the East Coast, the West Coast? Is it overseas? We find that a lot overseas where people in the UK are very concerned about their data here in the US. Because they're afraid that, because it's residing here in the US that the NSA has access just to copy whatever they want. So they want all their data sitting in their country over there in the UK. Very interesting process. And if you've ever tried to get data from overseas, we're talking about, you think a service provider process is long. We've talked to some law enforcement folks about how do you just get warrants overseas. It sometimes can take from the time a judge actually signs it to the time it gets in front of a judge in another country. It could be as well as excess of 10 years. So good luck on your forensic investigation. The data's a little stale. And then the ability to, like I said, to respond in a timely fashion, because those are critical. When there's an incident, you got to get in there. When there's a breach, you got to get in there as quickly as possible so that you can find all the pieces of the puzzle to make your investigation sound. And by having a delay, it makes it incredibly difficult. The database infrastructure. Now you're talking about shared environments. It's not just you clone this database server, but that database server may have 100 other tenants on it. So that means that that's going to be a process too, just grabbing what belongs to that particular customer. The chain of custody piece, like we talked about. How do you maintain chain of custody? When you submit a ticket, the ticket goes to the server admin maybe starts the job, and in the next shift come in, that guy finishes the job, closes out the ticket, sends a drive back to some customer service guy who then contacts you, and then puts it in the mail or however you want to get it. Chain of custody just became a nightmare. Who owns the data? Yeah, that's the big thing, because there's privacy that's entitled to the other tenants that are on that box. And there was Oregon State did where they talked about, regardless of where the data resides, the individual has the right to privacy. So that means that you just can't go clone a whole server, because then you just violated their privacy. You not only violated SLAs from the company, but you might have violated some laws in the process. So here's a nice little chart I found that NIST had out there, and they basically highlighted in green kind of a lot of the challenges that are happening, the jurisdiction challenges. We didn't even get into the legal issues of this because different states have different laws. For data reporting breaches, it all depends on what state you're in. It's different in every state. And it's not based on where the data resides, it's the data that was leaked. Where did those people reside? Those are the obligations. That's why you're seeing with, what's the one that just happened with Chase? You're seeing, attorney generals from California, Florida, all these other states coming in and making a big deal about it and coming over and investigating Chase. Why? It's an election year. They need to make a buzz, make people feel like they care, and They're looking out for their best interests. Just my opinion on that one. But, so it's incredibly challenging from not only a legal perspective, but from an actual investigation perspective. And there we go. And where the breakdown happens, where we go from traditional forensics to kind of network forensics, is really right there at the, right at this point right here in the middle. Because you still do the identification of evidence and the incident, but then somebody else has to do some collection, because you got to tell them what to do, you got to give them the basis, and then they have to go do the collection. And then once you get the data, you get to organize it, examine it, analyze it, and then you put together your presentation at the end. So again, in this aspect, seizing servers isn't an option. You can't walk in and just seize a server. The evidence based on the provider's word, you got to take that what they just said in that ticket, they did, you know, and that they followed some type of process, internal process for cloning these type of data. And that you're, as an investigator, you're very dependent on the cloud provider. And they can hold up your investigation by days and weeks because of their own internal processes. What happens if the guy copies the data, it comes back, and the security team says, well, this isn't sound data, you got to go do it again. Well, the original is already tainted now, so what happens? And unknown locations, as we mentioned earlier. So you got to really start thinking about network forensics. You know, because traditional digital forensics is not going to work within this environment. And there's many, many cases that are happening over and over and over in the cloud. But what we have as investigators to rely on are the capture packets, or PCAPs, log data, cloning servers. I'm going to tell you a couple of stories about that process. Looking for keywords and parsed data, you know, reviewing any type of IDF or WAF logs that are out there, and hope that they have these logs, and hope that they even have some technology out there that you can rely on to be able to grab sound logs from, because not everybody does. I mean, there's so many cloud instances that I've seen out there that a person's just rolling out some IP tables in AV and they're like, hey, I'm good. That might have worked 15 years ago, 20 years ago, but it doesn't work today. So having these technologies is the first step. You have to understand that these technologies are implemented, and how do I get the log data off it as quickly as possible, and hopefully they have an archive process. And understanding the service provider is very key. Because the service provider, if you think they're going to supply you with networking logs, firewall logs, forget about it. It's not going to happen. So that's where I kind of drew this up, where this is where the service provider's line stops and your responsibility as a consumer begins. So as you can see, they set up your computing power, your logical network segmentation, they harden hypervisors, they give you access, that kind of stuff. That's where they draw the line. That's all they do. From that, everything in those dark areas up here, as far as application, is 100% your responsibility. You have some responsibility at the host level for access management, patch management, at the network layer for network threat detection. And analysis of all this data is incredibly key. But not all consumers actually understand that. So when you go run an investigation, you might be dealing with an uninformed small business that just made a lot of assumption that this cloud provider did a lot more than what he actually thought they did. And that happens all the time. I mean, when I was working at a service provider, I got things like there's one instance was a New York financial company, and they had fired their system administrator on Friday. And so they went through, deleted his LDAP, his AD credentials, locked him out of their network, locked him out of the building, but they forgot to hit the cloud. So about 3 a.m., after the guy's probably been drinking all night, he goes out and he actually takes their whole infrastructure down out in the cloud. And man, those people called up pissed. They were like, man, our infrastructure's down, our site's down, we're processing no business right now. What happened? They were like, what, they thought it was our responsibility, but guess what? They didn't remove his access rights. So he logged in with valid credentials. So understanding how logins are taking place in the cloud allows you to log it too, because some people are integrating their cloud infrastructure with their actual Active Directory in their enterprise. and syncing that across the board so that they can have one central location delete all user access across everything, cloud and enterprise. So understanding that is definitely key for your investigation, because you have to understand where this line is, because any logs that sit in this space, you don't have access to. You're not going to get as part of your investigation. This is all you get access to as part of your investigation. So that's what we have to rely on to be able to put the pieces together, to put a case together, to be able to present. Enabling log solutions, that's a shared responsibility. One of the things, I'm going to make a shameless plug for Amazon, just because I thought they came out with some very, very cool technology this year. But they came out with CloudTrail, which they're the first ones to come out with the capability of you now logging the back end. So we always talk about logging the front end of an instance so that we know who from the internet is actually hitting our environment. But with CloudTrail, now you could log the back end. So any API calls coming from the hypervisor, any updates that they're doing to your environment, things like that. You'll be able to now log that type of data in that. So I thought that was a very, very cool, innovative service that they came out with, and they've been expanding it to now their database services and a bunch of other different infrastructure. So I think it's very, very cool, because I can tell you, I used to have to run a lot of cloud investigations at the service provider I worked at. And while I was there, about 98% of the servers that I touched were actually legitimately bad guys doing bad stuff. But there was that 2% that I touched that I went in and examined data because I had a report from a third party that I needed to go investigate, which were legitimate customers that were just doing regular business and nothing was wrong with their environment. It was a false alarm. So to be able to know that that's taking place, that's what CloudTrail allows you to do, which is very, very cool. Ability to perform some type of deep packet forensics, that's kind of my pipe dream right now. We don't have that today. I've been talking to some of the deep packet forensic vendors out there like NetWitness and Solaire about, we need to really get into that environment where we can start collecting deep packet forensics. And if you don't know what deep packet forensic is, it's like a TiVo for your network. I always recommend it for people who run incident response inside of an enterprise organization because it is TiVo. It records everything going in and out of your network, so if something happens, you can go back and replay that traffic. What email did that person click on? What link did they go to get infected? Actually pull the PCAP and pull the file that they got infected with and reverse engineer it without having to go to all the different desktops to touch them. Great tool to have, but I like to see it go in the cloud. IDS designed for the cloud, that's a tricky one because it's a different type. It's not the hardware IDS, IPS, you gotta have the agent. The NetFlow collection, that's actually something we're very, very close to. Not us, but some vendors out there in the industry that do NetFlow, as far as collecting NetFlow data from cloud instances. And I've always considered that kind of a poor man's deep packet forensic analyzer. Because you can deploy NetFlow a lot faster, and you can put some blacklists against it, see traffic that might be leaving a printer going off to a country overseas. We've seen a lot of that through NetFlow. Just weird anomalies you'll find through NetFlow. So I think NetFlow is a great step for them to be able to get to the deep packet forensic analyzers. There's a lot of applications out there for memory analysis that a lot of researchers have put out there, but it really, it's basically what you're comfortable with, what you're used to using. Multi-tenancy SLAs, very important because that you got to understand what your SLA is because you have to know where the boundaries are that you can run your investigation in. Because if you go any further than that, you not only taint your evidence, but you now just affected the privacy of other people that could be potentially on that box. So I'm going to run through a process that I did when we found some data a while back. So we were dealing with a customer who sold antique bathworks. Real cool guy. He has some really cool tubs and the old antique sinks and all that kind of stuff. And we found some unusual activity just occurring on his instance. So we got a friend of mine from a company that will be unnamed contacted me because he's a fellow researcher out in the industry. And he contacted and said, hey man, I'm seeing some data out of my organization leave and it's going out into your IP space. Can you go take a look at it for me? Sure, we'll go take a look. Two of us researcher guys went out there, took a look at the guy's server. Everything looked pretty normal. Well, we were like, all right, well, we'll just check his bandwidths and see, what's going on in the server. It was very, very steady, but then once every 2 weeks, you'd see a huge spike every couple of weeks. And we were like, man, that's kind of interesting. So we contacted the actual user at that point and said, hey, we want to move you and upgrade you to a brand new server into this environment, but we'd really like to keep this one intact because there's some unusual activity that's occurring on this server. So, of course, is he going to deny being upgraded for no additional cost to a new server? Jumped all over it. So that's what we did, was move all his data to a new server and redirected DNS. So then we started loading on some tools on this. We started loading on things like Wireshark and Network Miner on the actual box itself. And we started running a tap and running all his data through a forensic analyzer. And then we waited for the next attack. 2 weeks later, what happens? An unallocated IP space and the IP address of this guy's space gets activated, gets loaded as a remote access server, and then all of a sudden you see gigabytes of data floating into the server, floating out to another server in South Korea. And where it was coming from, we saw, I won't mention any vendors, but we saw interesting things in this data stream, like blueprints for test aircraft, helicopters, submarine propulsion drives. I mean, a bunch of interesting data. And we were like, this is kind of interesting. Why is it going to South Korea? They're our friends. Yeah. So it happens to be that in the stream that we were collecting had the username and password for the other server. So we kind of went and just took a look at the other server to see what it was doing. And we found that from there, it then was dumping all the data down into Beijing, China. But what was really successful for us is that if we would have had to do post-forensics on something like that, it would have been nearly impossible because of the way the guy was on there. He didn't modify the user's data at all. I mean, this guy processes credit cards, he has developers' usernames, passwords, he has all these things he could have done by stealing the actual customer's data. Didn't touch it, wasn't interested. He just wanted to use that server as a jump point. So by having the capability of loading these types of tools and running the forensic investigation live as it's actually taking place is the best key, because if you can get those initial indicators of compromise, that allows you to get in front of the attack. Let's start loading up the tools on the box that you can use, like Network Miner and Wireshark or whatever version of PCAP collection you want to use. And go out there and start collecting the data live. If you have access to a deep packet forensic analyzer, that's even better, because then you can, they have virtual instances that you can just pop out there and just run a tap off of it and start running it through there. Then you can help your investigation even more. But if we were having to come into this post, it would never have been this successful. We would never solve the attack. We would never been able to track it back to the actual origins that the data was going to and how they were attacking all the different organizations that were affected. So running this type of process, in my opinion, is probably one of the best ways to do forensics in the cloud, because traditional forensics is not going to work the way it used to. I mean, so we really have to rely on network forensics, which means we need to make sure that the customers that we're servicing are logging everything, and they're logging it properly, and that they're logging it for a sufficient amount of time, because logging is not cheap. I mean, that's just the way it is. But if you think about it, based on the Mandiant report this year, the average time that that an attacker is on a network, 229 days. So you know that you need to have at least that long of log data to be able to go back to the investigation to find out what happened in the beginning. Very, very key. Now, any questions on that, first of all? Questions, comments, concerns? All right, you're saving them all for then. All right, very cool. So there's some tools. Anybody remember Helix? Anybody remember Helix? The good old forensics tool that they kind of went to Helix Pro for and kind of let the free version kind of fall by the wayside. Andy Bennett, which he's going to be talking later today, and his crew over at Sam Houston actually revived the project. So for those that do forensic investigation, they came out with SciFix, which is basically the equivalent of what Helix used to be. It has the combination of all the tools that comes on. It comes in with a bootable CD that you can load up and launch and do forensics investigation with. It has some of the tools on there that you can use also in a cloud investigation. But I love to give him a plug on this because I was very frustrated. I mean, as many investigators were, anybody who was even playing in that space, that when Helix started really going by the wayside, probably be, what, 10 years ago, 8 years ago, something like that, where, you know, they stopped supporting the free version of it because they were trying to go pro, get everybody to buy the product, become the competitor FTK and Encase, that they kind of let it fall by the wayside, which was really sad because it was a great open source tool, and I mean, I used it a ton during my investigation days. So having this tool right here that Bennett and his team did is a great tool to use. So with that, I'll thank you for your time. Appreciate it. Remember, you know, when you're working an investigation, you got to remember 3 things. You're running a network forensic investigation, not a traditional investigation. So you have to rely on log data. You need to rely on security technologies that are deployed, being able to collect logs from those security technologies. You have to understand the relationship with the service provider that your customer has. You have to understand how the service provider functions and how they work. Then, if you find out you do something, you know, if they're coming to you because there's a live hack, you have a very good decision there to make, because then you can work with the service provider, have the service provider actually upgrade them to a new tier, and leave that original box live, because then you could do the forensic investigation live as the actual attacks are continuing to take place, which is key because the IP address doesn't change, and that's what the attacker is using. So it's a partnership between yourself as the investigator, the consumer of the service provider, and the service provider themselves. Combination of the 3 is what's going to help you have a successful investigation. So with that, I'll take any questions, even outside forensics. Come on. Yes, sir.
So how about the whole thing? Has this season already any kind of court, legal proceedings as the drug supplier, judges, what's happening on that?
Very good question. I haven't seen it all the way through the legal proceeding process, because what happened when we ran probably about 3 or 4 of these, because of the sensitivity of the data, usually law enforcement came over, took over the investigation, ran with it from that point forward. But they were extremely grateful that we had been collecting data for the last 2 months before they got there. We kept they said, according to the feds that showed up, the data was sound, the way we provided them was solid, we were giving them live captures of actual data versus actually cloning the drive. We were giving them to live data. So they accepted it, so I assume if they accepted it, also it would make the next tier.
You think about the service provider not allowing, like, don't touch, I mean, I've seen these contracts in this whole area.
Oh yeah.
Don't pen test us, don't vulnerability scan us, on and on and on and on,
Yeah, it's.
I had a customer, speaking about logs, so they reversed their file. So they had their stuff up there, and then all their logs came back to their own data center.
Oh, interesting.
So, and which I love from being forensics.
Oh yeah, absolutely.
Then I have access to it all day long.
Yeah.
So that's what they did.
That's very typical, where a lot of people who are running cloud instances are logging their solutions, their security solutions, and their server data to an instance sitting, either in the cloud somewhere else, or to their enterprise, or sometimes also to like managed security providers. So I've seen all those 3 different tiers within that environment. But you're right. I mean, once you get to a service provider and you try to walk into a data center, it's not going to happen, man. It just does not happen. It violates all the rules of their confidentiality agreements with all their customers. So, I mean, I've seen actual guys get fired for walking people out on the data center floor. So it became a big no-no. I mean, a C-level executive guy who was walking, giving a tour to people, he got fired, and that tour got terminated immediately as soon as they discovered that there were people that were not employees on data center floor, and they got rid of the C-level executive just for that very reason. So yeah, it's a very tricky situation, and that's why I say it's a true partnership, because you're kind of relying on that service provider that they gave you the right data, and there's a lot of what ifs involved. So that's why I'm a big believer in, if the breach is going on right now, let's get them upgraded. Let's do it live right now, because then I don't have to rely on that server administrator to, clone an instance. I don't have to rely on him to give it to the customer service. You bypass that whole process and actually collect the data live as it's taking place. Yeah. Yep, failed. Check mark, yes. Yes, ma'am. I have not. Anybody else? Okay. I will hand it back. Thank you very much.